22 now, we have balance this equation and it calculate how many grams of lead 2 sulfide form when you use 26.11 grams of lead acetate and an excess / unlimited amount of dihydrogen monosulfate, or would it be dihydrogen sulfate? Well, nonetheless, let's see what we can do here. So we have, that's a big molecule, PbC2H3O2 2 plus H2S gas turns into lead sulfide, as they said, plus, yeah, we might need more space for this, HC2H3O2. So the way I like to separate this in order to actually balance this out is that I like to note the parts that I guess come together. We have this, two of them actually, of the C2H3O2, but this only accounts for one of them. So one of the easiest thing we can do actually is just double this. Just add a 2 right there. Okay? And now, with that being said, you're probably wondering, what about the hydrogens? Funny enough, it actually balanced itself out because we had H2S. So just by adding the 2 here, we balanced out the whole equation. So we are actually done. And now they're asking us how much lead sulfide forms when we use 26.11 grams of lead acetate, which is what that is, and an excess amount of H2S. So that just says excess, and they want to know how much of this, the lead 2 sulfide. Okay, so with this being said, we need to first go ahead and convert this to moles. Then we do the mole ratio. Luckily for us, it's 1 to 1. And then we convert that back to grams again. So we need 2 molar masses. The first one is a molar mass of lead acetate. So that would be, count the constituents, 1 lead. And now we have to multiply everything in here by 2. So be wary of that. We would actually have 4 carbon, 6 hydrogen, and 4 oxygen. So it's looking so far to be quite a big molar mass. So we have lead. Lead is all the way here. There we go. 207.2. And don't know why I wrote a 6 there. That should be carbon. 12.011 for carbon, 1.008 for hydrogen, and 15.999 for oxygen. Luckily for us, there's only 1 lead, so that's 207.2. And then the carbon is 4 times 12. That's 48. This is 6.048. And the oxygen, 15.999 times 4, 63.996. Okay? So with that being said, we have 207.2 plus 48.044 plus 6.048 plus that 63.996, and we get in total 325.288 grams per mole. And now for the lead sulfate, we need to now do just 1 lead, okay, and that's 207.2, and 1 sulfur, which is 32.06. So luckily, well, actually not so luckily, these numbers do vary quite a bit, and this would be 32.06. So 207.2 plus 32.06, we get 239.26 grams per mole. Okay, so quite different. So we're going to set up in terms of conversions. We have 26.11 grams. Okay, and we want to convert this now to moles. That'll be 325.288 grams per 1 mole of lead acetate. And now, as you can see, based on the formula, for every 1 mole of lead acetate, there is 1 mole of lead sulfate. And then as a last conversion, we have, for every 1 mole of lead sulfate, we have 239.26 grams. And if we cancel our units, we end up with the right grams. So with that being said, that's 26.11 divided by that 325 times that 239.26. And in the end, we get 19.20 grams of the lead sulfide. Okay, that should be what it is, PBS, lead sulfide. So, with that being said, let's see what our colleague got. We have this, and they did balance it out, which is perfect. All they did was add the 2 there, as we did. Okay, and they got the formula here, and they do got the 325.3, which is close to what we got, and they got 239.3, which is close to what we got as well. By doing that and multiplying everything, they got 19.20 grams. Okay, and this is how they got the answer, and that is correct. So with that being said, we've now solved question 20.